Greetings all. I'd like to revisit the topic of replication. Some of you might ask why this question is still on the table. Multiple anomalies have been observed that require a nuclear explanation. Access to a new primary energy source seems at least possible. The field of condensed matter nuclear science began with palladium and deuterium, and the example I give at the bottom here demonstrates the isotopic effect of deuterium in electrolytic experiments. But this field has broadened and the range of anomalies has expanded. We as a community are convinced that there is at least something real that needs a nuclear explanation. My personal list of nuclear necessary anomalies includes the production of tritium in a chemical environment, the Fleischmann-Pons heat effect itself, production of helium-4 and its correlation with measured excess heat. In this, the key is correlation. The example I give is from our efforts to replicate less cases results, and the correlation is obvious. Many other nuclear products and effects occur that are inconsistent with isolated two-body nuclear reaction. The breadth, depth, and number of anomalous results is huge. This magnitude is the most powerful single argument we have that low-energy or condensed matter nuclear reactions exist. Much of the early material was published comprehensively reviewed by Ed Storms in his first book in 2007. This remains probably the best argued case for the reality of condensed matter nuclear reactions. The evidence is overwhelming based on the totality and complementarity of results, but it is not based on any specific result. Despite what I'm calling overwhelming evidence, we do have a real problem, and our problem is getting worse, quantifiably. Outside interest in our work today is no greater than it was 2 decades ago and substantially less than it was 1 decade ago. We're losing public interest. The blue plot is of data from Jed Rothwell's site showing the monthly download rate of CMNS articles in units of 1,000 articles downloaded per month. The total integral download number is 4.8 million, which is very impressive. It's the shape that concerns me. These data highlight the problem, but do offer a reason for hope. This conference series, the ICCFs, apparently has had an impact on public interest. The black spikes at the bottom on the timeline are the ICCFs, which closely correlate in some cases with the spikes in public interest. I don't know of the origin of the spike of 30,000 downloads in the month of April 2006, but many of the rest of the features closely correlate with the ICCF conference series itself. If you look at the graph, you can see that Washington, D.C., Chennai, Daejeon, Sendai clearly made a difference. Our record download rate of 52,000 per month coincided with ICCF-20 in Sendai in October 2016. But the exponential drop in interest that followed Sendai is perplexing and very concerning. A similar drop occurred after Assisi in 2019. We need to figure out why we're losing public attention, reverse this trend quickly, preferably here in Xiamen. What's the solution? Replicate, replicate, replicate. In essence, my proposition has 2 points. Reproducibility on demand in multiple laboratories, followed by joint open publication, will open all the doors we need to funding, acceptance, fame, fortune, whatever. We don't have that yet. To pass the test of replicability, I assert that one of 2 things must happen, probably and preferably both. We need to show unmistakable and irrefutable scientific proof that nuclear effects take place in condensed matter by mechanisms different from the reactions in free space. We must demonstrate a path to practical use, or at least practical potential, of the energy so created. Why do I insist on practicality? Well, nuclear proof without at least the suggestion of practicality has not worked for us. And I offer you the case of tritium. Tritium is a nuclear product most certainly produced in many CMNS experiments. The original evidence of tritium came to us pre-reproduced in the work of Stormson, Talcott, Bockris, and the work at Bach. More than one group produced tritium. It all came along early in our field, more or less simultaneously. These three different sets of experiments supported each other, and one could say that the effect of tritium came already reproduced, or came to my attention already reproduced. There are more examples. The image at the bottom is from our replication of Arata and Zhang's double-structured cathode experiment, and shows the profile of helium-3 as the decay product of tritium which diffused from a source inside the electrode. From the timing and the magnitudes, we know that this tritium source was created sometime during the period of electrolysis in D2O. Converse is also true. Practical possibilities without theory has not worked to convince the world of the existence and potential practicality of cold fusion. A physics-based theory would certainly help recruit the generation of scientists we're going to need to complete the work that Martin Fleischmann and Stan Pons started. The example I give at the bottom suggests that we already have demonstrated a pre-prototype device in the work of Energetics Technologies Incorporated. Using Irv Dardik's superwave electrochemical stimulus, ETI were able to boil water 1.1 megajoules using only 4% of the input energy cost. An energy-cheap water boiler would have very wide practical acceptance. But this example also highlights the problem. Working with DARPA funding at SRI and ENEA, and at ETI with their own funding, we were able to replicate the effect, but not the scale or the timing. I've presented this plot many times. I'm proud of it, partly because of the huge amount of experimental work that this graph codifies. 67 PD D2O calorimetric experiments at SRI, a total experiment duration of 7.5 years. The black line is our resistance ratio versus loading curve. Experiments are plotted at their position of maximum achieved loading on this curve. The point color coding, red and orange, signify excess heat. The other colors, no excess heat was observed. If you look at equation 1 at the top, it's purely an empirical equation based on this data set and quite a lot more data. But excess power was found to be proportional to the product of three terms. The deuterium to palladium loading ratio, X, above some loading threshold, X naught. This this term is parabolic. The current density above a significantly non-zero current density threshold, and the flux of deuterium through the electrolyte interface, irrespective of sign. When you move deuterium in, loading. When you move deuterium out, unloading. In either direction, the flux of deuterium is proportional to the observed excess power. Focusing attention on the bottom right quadrant of this graph, every experiment that met the criteria of equation 1 demonstrated the Fleischmann-Pons heat effect. Every experiment except one, ETI 035-9, which met the conditions of equation 1 but did not yield excess heat. It yielded a very significant amount of tritium. I claim that this demonstrates reproducibility, but not full replicability on demand. Condensed matter nuclear science in many forms is reproducible. Many effects have been reproduced. Similar results and effects can be produced on more than one occasion and in more than one laboratory. Here is a list of 4 classes of examples where CMNS results have been reproduced. I'll let you read them, but the totality is remarkable. I claim that replicability is a more stringent condition than reproducibility, although if you look in the dictionary, the 2 words are defined in terms of each other. But the way I use replicability, you must be able to repeat the experiments of others in detail, at will, with the same results, including magnitude and timing. We have yet to achieve this standard. I would love to be proven wrong, hopefully this week. There are mitigating factors. Even at 30+ years, our science is still young and underfunded on the scale of the material's complexity. As far as I'm aware, Georges Longchamp and his team in France were and are the only group ever to attempt an exact engineering replication of the original Fleischmann-Pons experiment. They succeeded by understanding the experiment first and changing nothing until they had understood it. Longchamp called this mastery. He mastered the experiment first in order to study systematic effects. Then they were able to confirm the general results of Fleischmann and Pons, particularly with respect to the effect of temperature. I know of nobody and no experiment that demonstrates complete or effective mastery over experiments in CMNS. 2 reasons for this are: our greatest single problem with reproducibility is the compulsion to improve before mastery is achieved. We are moving the target ourselves. We also suffer from imperfect communication, and some of the reasons for this are expressed on this slide, but the Google team's initial, at least, inability to replicate, which they reported in their Nature publication, is our failure to communicate clearly and with sufficient detail and accuracy to allow replication. It's our fault. If you reproduce all necessary conditions, you will reproduce the result, whatever its cause. To make this happen, we need to do 2 things much better: communicate and collaborate. As Matt Trevithick quoted me in his opening plenary, collectively we have the answer. Individually, none of us does. A lot of the needed information is out there. Some of it is concealed. We need to stop keeping secrets and stop ignoring or forgetting previous work. As a community, we have the capacity to resolve this matter and do a lot of good for science and the world. As a personal comment, and despite my critique, I would like to close by saying that this is the finest community of scientists that I have ever worked in, containing the most serious, intelligent, and able experimentalists that I ever met. Not all have survived. We need help. This slide acknowledges the enormous number of highly talented individuals that worked with our group at SRI to achieve the results that we achieved. I draw your attention to the names in gray and italics. These 17 individuals are no longer with us and are some of the most able individuals that I ever met. My thanks to them, my thanks to this list, and my thanks to all of you. Thank you.